Okay, students, 3.1 graphing f of x is equal to ax squared. This is the beginning of us graphing the quadratic part of the quadratic function, or a quadratic function. We're eventually going to get to f of x is equal to ax squared plus bx plus c. And that's going to be in 3.2, lesson 3.2, and lesson 3.3. Okay, so we're gonna get through to all of that this week. Please stop the video, go ahead and write out the outline. Yes, there's a lot of vocabulary. I am introducing and we're talking about the quadratic function. Maybe you've seen it in Math 1, maybe. Hopefully your teacher talked to you about it, but if not, I'm here to remind you some parts of the quadratic function and the parent function. All right, let's go ahead and get started. So vocabulary. Well, first of all, the essential question is, what are some of the characteristics of the graph of f of x equals ax squared? So as I mentioned before, we're going to build on this as we dive deeper into our textbook. And when we get to 3.2, it's going to be ax squared plus c. And then when we get into 3.3, we're going to have it in standard form, which is ax squared plus bx plus c. Okay. So quadratic function, there it is, ax squared plus bx plus c. A cannot equal 0, because if a is equal to 0, then we would have a linear function. The quadratic function is a U-shaped graph, whether it's opening up, opening down, and the parent function is going to be y equals x squared. So that's what we're going to be comparing it to in this section. The vertex is the lowest or the highest point on the graph. So the vertex in this case would be the lowest point on the graph. Here's the vertex in example 1a, and here's the vertex for example 1b. In this case, these are all the lowest points of the graph. If the graph happened to open down, then it would be the highest point on the graph. Again, that's the vertex. The axis of symmetry, instead of writing it over and over again, we're going to abbreviate it AOS. This is the axis of symmetry. The axis of symmetry is a vertical line, and it cuts the graph into two equal parts. It goes through the vertex. So the AOS is a vertical line. It goes through the vertex. And so we're gonna, and it like I said, it cuts it into two equal parts, so we have a mirror image. Okay. So here's our vertex. Our vertex in this case, it is a point. So in this case, our vertex is 0, 0. Our AOS we will use. I will use a highlighter, and I'll use a pink highlighter. It could be a dotted or a solid line. Again, it goes through the vertex, cuts the parabola in half. The AOS is also the x coordinate of the vertex, so we would write x equals 0 if they're asking us. When you're reading a graph, students, when we're talking, they're going to ask you about behavior in example 1a, and it could be known as behavior or end behavior, and basically that's what's happening with the graph. So when you're looking at a graph, you always want to read the graph from left to right, right? From left to right. So in this case, this part of the graph is actually going down. And so we call that decreasing. So this part of the graph is decreasing. Again, we're reading it from left to right. So to create that, it's decreasing from left to right. And then to the right of our AOS, it's increasing. Whoops. Again, we're talking about from left to right. So it's decreasing, it hits the vertex, and then it's going to increase. Okay. I think that's all that I want you to know now. example 1, they're going to give you a graph and they're going to ask you to identify the characteristics. These are the things that you want to make sure you hit. They're going to ask you vertex, the AOS, axis of symmetry, the behavior, increasing and decreasing from left to right, domain and range. Again, you guys know how to identify domain and range, so I'm not really going to talk too much about that. If you don't know how, you need to look that up yourself. Remember, domain is the X values, range are the Y values. So we're looking at the graph again. Okay, so example 1, let me just read it to you. It says, consider the graph of the quadratic function. Using the graph, you can identify characteristics such as the vertex, axis of symmetry, the behavior of the graph as shown. You can also determine the following: the domain, the range, and again, the behavior of the function is decreasing or increasing. Okay, so the first thing I want to look at is, again, you have this graph already written out or drawn on your paper. You can use graph paper if you like, but it's just, I gave you the coordinates. On the y-axis, we are going all the way down to -2. On the x-axis, I've identified -1. So the first thing it's going to ask you is, what is the vertex? Well, the vertex is this point right here. It's the lowest point on the graph. And so we know it's going to be -1, comma, -2. So that's your vertex right here. Okay, the next thing we want to know is, what is the AOS? Remember, the AOS is vertical line that cuts the parabola into 2 equal parts. It is also the x-coordinate. So the way that we would write this is x equals, wherever it crosses the x-axis at -1, so x equals -1. Notice how, as I mentioned before, if you're paying attention, the AOS is the x-coordinate of the vertex. Okay, so you'll notice that those match up. All right, behavior. So what's happening to the left of the vertex versus the right of the vertex? So remember, we talked about increasing and decreasing, and we can just simply write that out. So here, the y values. So again, when we're looking at what's happening to numbers that are greater than -1, or I'm sorry, less than -1, we know that the y values, so let's write that down. X is, when x is less than -1, which is here, these are all these numbers here. We can write y, the y values, y increases as x values decrease. Okay. Again, this function is from the left-hand side of that vertex, it is decreasing. Okay. So, that's when this is to the left of the vertex. Okay, if we're reading it to the right of the vertex, again, I'm running out of room. We can put when x is greater than -1, so everything to the right, our y values increase as x values increase. They're both increasing. Okay, so your y values, again, it's increasing, so it's going up. At the same time, we're now dealing with, as it's increasing, the y values are, our x values are also positive, so they're also increasing. Okay, so that is our behavior. Again, here we're decreasing. From the left of the vertex to the right of the vertex, we're actually increasing. we're decreasing and increasing. Okay, domain. Domain, remember domain is we're looking at all the values of the x, okay? And all the values of x say this. Because we have arrowheads here, that means that it's going to keep going and it's going to cover all the x values. So how do we write that? You could write all real numbers. You could write this letter R. It looks like an R. This means all real numbers. Okay, so our domain, it says that we're going to cover all the numbers. It's not going to stop. It's going to be continuous. Range, there's actually an endpoint. Notice how the graph doesn't go beyond this point. So what number is that? That's a -2. And so what we want to do is say, hey, our range is everything that is larger than -2. And so how would you write that? Y is greater than or equal to -2, because we want to include -2. That's why it's greater than or equal to. Again, we're going to include it, and so it's going to be, nothing is going to be below -2. It's going to be everything above it. Okay, so that's your domain and range. So I think that's everything. Identify the characteristics, the vertex, AOS, behavior, domain, and range. Okay, so when you see that on your homework, those are the things that I'm going to ask you guys to write. Okay, so again, if you have any questions on any of these, you can ask me during class. Again, domain and range is a Math 1 concept, so you're going to have to look that up yourself. Just find a video on YouTube, or you can Google it, or you can look at last year's notes. So we have another graph. We're going to do the exact same thing. We're going to identify these characteristics. Again, let's go ahead and talk about this vertex. It is a point. There it is. Again, it's the lowest point on the graph. And our vertex is 2, -4. Over 2, go down 4. That's where it's at. Our AOS, it could be a dotted or a solid line. Because I already have solid lines here, I'm just going to create a dotted line. Okay, it really doesn't matter. AOS is your x coordinate of the vertex. So let's just make sure it matches up. It sure does. So we know that x equals 2. Again, I'm showing you on the graph, and I'm also writing it out here on the left-hand side. Behavior. So remember, to the left of 2, it is decreasing. So to the left of 2, it is decreasing. So when x is less than 2, so these are all numbers that are less than 2, right? Our y values are increasing. So because the graph, well, let's write this down. Y values are increasing as the x values are decreasing. Okay, so as we create this graph, as it keeps going, it's gonna, if you're looking at your y values, it's gonna be increasing. But as it gets further and further out to the left, these numbers are going down. So that's why x values are decreasing. These numbers are going up, getting higher and higher, okay? All right. So what's happening to the right of the vertex? Well, when x is greater than 2, they're both increasing. Our y values are increasing. So I'm just going to write this. Y increases as x increases. Okay, you can simply write that if you like. I think I was writing too much at the beginning. Okay, and I'll understand what you're saying. So everything is going up and we're increasing. Remember, we're reading this from left to right. Okay, domain. Whoops, sorry. Domain. Again, we have arrowheads. We don't have any endpoints, so it's gonna keep going and it's never gonna end, right? So all real numbers. Our range. Our lowest point, okay, it doesn't go past -4. So it's everything that's above negative 4. So these are values. Y is greater than or equal to negative 4. Okay, that's our domain and range. Everything that's above negative 4. All right, let's keep it moving. Let's talk about more of this function. This, I would have to say, besides, this is the second hardest chapter in the textbook because students are not used to all this wonderful information about quadratic functions. And so I'm telling you right now, if you understand it and if you just practice at home, that's why you do homework. That's why we do classwork and warm-ups and pair decks and whatever else, exit tickets. We're practicing. Okay, we're not here to overwhelm you, but we got to practice these because if you're not used to seeing this, then of course you're not going to do well. But if you're familiar and you're used to seeing them, yes, you can do well. Okay, so we're talking about, here's our parent function, f of x is equal to ax squared. We haven't built anything. We haven't built or added to this quadratic function. So we got to learn this before we move on to 3.2, because if you forget this, then 3.2 and 3.3 are going to be very difficult for you. We're looking at our coefficient a if a is greater than 1. So if this number is greater than 1, let's say it's 2, 3, 5, 100. We call that, when it, on the graph, if we were to graph it, we call it a vertical stretch. So in black, I tried to color code this. In black, we have our parent function. And then anytime that a is greater than 1, let's say we have 2x squared, we call this a vertical stretch. And what it's doing to the graph is actually narrowing or thinning out the graph. And I'll show you more of that when we're online. I'm actually recording with my cell phone, and so I wanted to, there's an app that most of you guys are familiar with. When you start changing numbers on the quadratic function, you'll see how it changes. Okay, so the vertical stretch, again, if a is greater than 1, so like 2, 3, 4, 5, 1.5, 2.5, 1.75, 1 point whatever. Okay, so anything that's greater than 1, we're gonna have a vertical stretch. Again, it's stretching vertically, so it's getting it closer to the y-axis, so it's like pulling it. And that's why we call that narrower, or it's getting thinner when we're comparing it to the parent function. Okay, what are some examples? You might see, as I mentioned, y equals 2x squared, or it could be written out as f of x is equal to 5x squared. Again, we're looking at that a value. Okay, we're looking at that a value, and we're saying if it's greater than 1, okay, this is what the graph will look like when we're comparing it to the parent function, okay, which is y equals x squared, okay? All right, next thing I want to talk about is what happens when a is less than 1 but greater than 0. So less than 1 but greater than 0, so like 0.5. So we're dealing with fractions or decimals. 0.5, 0.32, 0.3. This is what we call a vertical shrink. That really means that the graph is going to get wider. So again, in black, we have the parent function and then the vertical shrink. Let me give you an example. If you have, y equals 1/2 x squared, that's going to make it wider. Maybe you have something like f of x is equal to 1/3 x squared. Again, we're looking at the a value, and if it's less than 1 but greater than 0, okay, not negative, less than 1 but greater than 0, then we're going to have like that more of a wider effect when we're comparing. Okay, a couple other things I want to talk about. If a is negative, here's the negative part. If a is negative, we call that a reflection in the x-axis. When we have a reflection in the x-axis, that means that the graph is opening down, okay? If there's a negative, If A is negative, it opens down. If it's positive, as you can see, it's opening up. That 2 represents a vertical stretch by a factor of 2. Okay, so we talked about when A is here. Okay, vertical stretch by a factor of 2. There's a 2 there. This would be a vertical stretch by a factor of 5. Okay, and we'll talk about this, I think, in the next section. I don't want to introduce that to you yet. Okay, so a couple of things. Let's jump into example 2. I believe we have example 2, A and B, and then we're done for 3.2. So a lot of information, I know, students, but you can always, refer back to this video if you're still, you still have concerns. Okay, so example 2 is going to ask you to graph y equals ax squared. Graph g of x is equal to 2x squared. Now, some students are like, what is g of x? G of x is just, we know it's not, it's the new graph that we're going to compare to the parent function. So we know the parent function is f of x, g of x. It's just naming it, if we have a purple graph and a green graph, purple graph and a green graph, okay? Just another name. So we're going to compare these two. All right, so the first thing I need to let you guys know is let's graph this parent function first. If you have graph paper, that's fantastic. You can use it. 1, 2, 3, 4. 1, 2, 3, 4. So this is -4. This is +4. We'll go up 4. 1, 2, 3, 4. 1, 2. Okay, -2, and that's +4. Okay. When we're graphing the parent function, again, I'm going to color code this so you know. The parent functions, we're going to use a table. The parent function is -1, 0, and 1. And the parent function is always going to be 1, 0, 1, the y values. Okay, so how do we get that? We take this -1, we plug it in here. -1 squared is +1. 0, 0 squared is 0. Take this 1, 1 squared is 1. So this is never going to change. This is our parent function. So I'm going to explain this one time, and then I'm just going to use it for our next graph. And I expect you guys to do this as well. Okay? So what I'm going to do is I'm going to create points. Well, I already did, sorry. I'm going to graph this -1. So here's -1, up 1, 0, 0, and then 1, 1. Okay? So this is the parent function. This is what we're going to be comparing it to, right? It's U-shaped graph. It's not a V. Okay? If you put a V there, students, in your homework, on your notes, I mean, you're not going to get full credit. A V is absolute value. A V represents something's absolute value, okay? Which I think we're going to get into this year. Can't remember. So please, it's a U-shaped graph. All right, there it is in yellow, in highlighter. And we're going to compare it to, we use pink. Okay, so I'm still going to use the values. Easy values, -1, 0, 1. And basically what you're doing is taking this -1, you're plugging in here. And this is what I'm thinking in my head. 2 times the -1 squared. We're following the rules of PEMDAS order of operations, okay? -1 squared is 1. 1 times 2 is 2. Okay? I'm thinking in my head, this 0 squared is 0. 0 times 2 is 0. Okay. 1 squared is 1. 1 times 2 is 2. So these are the points that I'm going to plot. And this is going to be my g of x. So we have f of x, which is what we're comparing it to. And this is going to be g of x. Now, let's say he didn't ask us to graph. we can tell what's going to happen. Okay, let's do that first. Let's just say it didn't ask us to graph, and it just said compare it to f of x. We can do that by looking at the equation. Okay, what does that 2 represent? If a is greater than 1, it's 2. We know that it's going to be narrower or thinner than f of x. So it's going to look something like this. And we're going to call that a vertical stretch by a factor of 2. Okay, we can talk about some other characteristics that they have in common, okay, with the parent function. We can do that as well. We're actually going to do that. I like that. Okay, so I'm going to go ahead and graph this. We have -1 up to, we have 0, 0. Okay, I'm looking at some things that are the same, 1 and 2, 1 and 2. So I'm going to connect. Isn't that what we said, students? We said based off the equation, when we compare this g of x to f of x, we said just by looking at this 2, it's going to be a vertical stretch by a factor of 2, which means the graph is going to be narrower, okay, or thinner. I just feel weird saying that word. Let's just say thinner. Can't say narrower. Is that even a word? I don't even know. It is a word, but it is going to be thinner than our parent function, okay? All right, so we know that, let's write this down. There's a vertical stretch by a factor of 2, so we know it's going to be thinner. Okay, let's talk about the vertex. What's happening when we're comparing the vertices or vertex? Yeah, vertices. They're the same. They're both what? 0, 0. So same vertex, which is 0, 0. What about that axis of symmetry? Oops, AOS. What is it? So if we were to draw that, whoops, vertical line, notice how it crosses at 0. So the AOS is x equals 0. They're the same. They're both x equals 0. And another thing I want to talk about is they are both opening up. Okay, so we don't have a reflection. There's no negative. They're both opening up. Okay, so we got a couple things going on. G of x, we're comparing it to the parent function. We created a table. We still use -1, 0, and 1. We're always going to use this for our parent function. We're always going to get the same output, same y values. Okay, this is not going to change. We're also going to do it on the next example. And then a couple of things we talked about, what A was, what this 2 represented, okay, and it made the graph thinner. It has the same vertex, same AOS, axis of symmetry, and notice how they're both opening up. Okay, whew, let's move on. Last one, B. Okay, we're going to do the exact same thing. Oh no, we have a fraction. Students, we can do this. We can totally do this. Okay, I am going to change my y values based off the function h of x because it is -1/3. So I'm thinking of -3, 0, and +3 because I know that can divide out evenly. So you want to keep it, anytime, you know, if you have 1/2, you can use -2, 0, and +2. Those are some common fractions that you'll encounter, okay? So parent function, this is still the parent function, y equals x squared, or even f of x is equal to x squared. Remember, if you look on the previous page or your notes, we're still using -1, 0, and +1. Our output is 1, 0, 1. Okay, so that's what I'm going to graph. 0, 0, 1, 1. Okay, there's my parent function. There's f of x. You can also label it if you like. If you're not color coding it, that's fine if you're not using any highlighter. I'm just trying to show you that all of this belongs to the parent function. Okay, and what color did I use? Pink? All right. H of x, again, it's just another name, just saying that it's not, we're comparing this graph, this pink graph, to the yellow graph. Okay. All right. Let's just, even before we graph it, let's talk about some things that we learned on the previous page. First of all, there's a negative here, students. What does that mean? I don't know, Mrs. Holmes. I wasn't paying attention. I forgot. There's a reflection in the x-axis. And then we have this 1/3. We have a fraction, which is 1/3. So that means that it falls here in this area. That means it's going to be wider than our parent function. So it's going to be reflecting, it's going to be opening down, and it's going to be wider than our parent function. So it looks like the red, but then if we reflect it, it's going to be wider. Okay, so those are some things that we want to make sure match up, right? Okay, so remember I have negative 1/3. I want to use -3. Remember, you always want to use positive and negative numbers. 0 and +3. Okay, and then what is that going to look like? Negative 1/3 times -3 squared. Okay, and if you want, you can do that. It doesn't matter. But let's just simplify it. -3 squared gives you 9. So watch what happens. And then when you multiply, because that's what's happening here, multiplication, you end up with -9/3, which gives you -3. Okay, so when I graph this, it's going to be -3, -3. All right, 0. 0 squared is 0. 0 times -1/3 is 0. Okay. And then -1/3 times 3 squared. Again, you can put 3/1 if you like. We end up with -1/3 times 9/1, which makes it -9/3, which means it's -3. So when I graph this, it's going to be 3, -3. Okay, so let's go ahead and do that now. Again, this is h of x. So -3, 1, 2, 3, go down 3, 1, 2, 3. Again, if you have graph paper, this would be so much easier. So 1, 2, 3. Okay. Connect. Again, try making it U-shaped graph. There it is. Okay. Take a look at that, students. Woo! My textbook just fell. Here's our parent function. Remember we said that negative is going to be reflecting off the x-axis. So now it's going to be opening down. That 1/3 says, hey, it's going to be wider. And if you look at the two graphs, it is wider. It is wider, okay? So please write that down. I also need you to write down that it has the same vertex, which is 0, 0, the same axis of symmetry, right? It's going through the vertex. H of x opens down and h of x is wider. Okay, so let's write that down. Same vertex, 0, 0. X equals 1. No, 0, sorry. Where did I put 1? H of x, remember, opens down. And we said h of x is wider. Okay. All right, we are done for today. Thank you.